All right, so I think we're ready to go. Begin the next question. Let me check that the audio is working. Give it a moment. Hello, hello, hello. It's working. Give it a moment. Hello, hello, hello. It's working. Give it a moment. Okay, very good. So that's working. Wondering if I should change the camera angle. I don't know. You can't really see much of my body, and I think people, it's kind of funny. They like to see like a physically, um, people kind of like judge you by your physical appearance, believe it or not. Wondered about that with cameras and stuff. Like maybe it's worthwhile to be a little bit more like I go to the gym quite a lot, but I'm not. You can't see. It's not my upper body that I work on that most, and the camera is usually just on the upper body. So I've kind of been thinking about that lately. Like maybe I should be focusing on my upper body strength. It's not really good. It's good for the camera, but it's not really good long term for your life. It's better to work on your legs mostly, which is mostly what I've worked on in my lifetime. So I have very strong legs. But anyway, thoughts for another time maybe. So next question here. A conveyor belt has packages that must be shipped from one port to another within days. The ith package on the conveyor belt has a weight of weights of I. Each day we load the ship with packages on the conveyor belt in the order given by weights. We may not load more weight than the maximum weight capacity of the ship. Return the least weight capacity of the ship that will result in all the packages on the conveyor belt being shipped within days. Example weights 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Days 5, output 15. Ship has capacity of 15. Is the minimum to ship all the packages in 5 days like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Note that the cargo must be shipped in the order given, so using a ship of capacity 14 and splitting the packages into parts is not allowed. Oh. What? Isn't this like a really easy question? Wait a minute. Am I missing something here? Isn't this like very easy? Days 3, weights, output 6, capacity of 6 is the minimum. Oh, yeah, never mind. Excuse me. There's a. Oh, I see. Yeah, you can do this in a relatively straightforward way. I'll explain how this can be done. But this is like a binary search type question. I'll explain. Yeah, it's not that easy. This is easy, but it's not that easy. So weights 1, 2, 3, 1, 1. Days 4. The lowest capacity is 3. Okay, to do it in 4 days. So 1, 1, 1, 2, 3, 1, 1. Okay. I see what they're getting at. Yeah. This is so these sorts of questions. I mean, I'm familiar with these questions now. I can do them very quickly when you recognize them. When you don't know how to do this kind of a question, it's really challenging. But basically, this is a binary search. You just binary search on the capacity size, and what you're going to do is just check if with that given capacity size, how many days it takes to handle all of the packages, and that's it. And then if that number of days is less than or equal to the days required, then that capacity is one you can use. Otherwise, you would binary search onto a different capacity. Either have to increase so that you have can do it in fewer days, or decrease so you can do it in or decrease so that way you can try to decrease the capacity. Yeah, this is just like a binary search. So calculation, usually you just have like a calculation that you perform as a subroutine. You have A, B, and best for your integers. The best is, so we want the lowest capacity. So the highest capacity would be basically the sum of all the weights. You do it in 1 day, always. The days are always at least, yeah, so you can take sum of all the weights. The sum of all the weights, it's going to be 50,000 times 500. 50,000 times 500 would be like 25 million, something like that. So you can do 25 million is something like this. You could just make this put this way up there. That's the highest capacity. Yeah, the lowest capacity could be a 1, the highest capacity could be that. And the calculation we'll go through in a moment. So basically you have a while loop, a is less than or equal to b, constant mid is going to be b plus a plus b minus a, bit shifted to the right 1. Constant val equals calc of mid. If the value number of days is less than or equal to days required, then we update our best to that midpoint. And in both cases, so here we can go smaller. We can update A to, B to mid minus 1. On the other side, we want to go larger, mid plus 1, right? If our value took more days than we have available, right? And then the calculation is very straightforward. It's just going to be capacity, we'll call it C. With a certain capacity, we're going to say how many days does it take? It's sort of a while loop, I guess. Int I is 0, I is less than, we'll just say n is weights.size. I is less than n, increment I. We have int current equals 0, another for loop, j equals I, increment j. We're going to say current is less than C. We're going to update current to the j is less than n. Current's less than C. Current plus equals weights of j, increment j. I is equal to j. And in fact, you could not even use j, you could use I. Really, I think you can, quite frankly. In which case, you don't even need to update I. Yeah, and then we just have a count at the end. And return the count. So the way this works is you start I somewhere and you increment I as long as this current value is less than 0, and this even could be its own. Yeah, as long as the current value is less than or equal to the capacity. No, it's less than the capacity. Then you can add more to it, right? It's a little more sophisticated than that. It's going to be current of weights of I, and I is less than n, and current plus weights of I is less than the capacity. Then we're going to update current and increment I. A little more sophisticated, I guess. The idea is that we don't add something to current unless it fits. If it does fit, then we add it, and we stop for a given I when it doesn't fit anymore. And then we also say, we also would say count is less than, another issue here is that, yeah, we could do int j equals I. Actually, that might be better. Let's try it this way, actually. I'll explain in a moment why I want to do it this way. if current is greater than C, then we break. Right, this basically means that it's not possible actually to fit all of the weights. You know what? Actually, a better thing to do. Let me go back here. Let's keep making it a little bit simpler. Let's just make this be let this be the minimum. That makes this a 2-pass routine, but that doesn't really matter that much because yeah, when I'm going through it, all this extra, all these if else's makes things so much more complicated. I think something like this works. This is a simpler way of doing it. Oh, okay. I forgot. I forgot that's different routine. Something like this. Uh-oh. Oh no, doesn't end. Uh-oh. Uh-oh. Oh no, come on, really? Oh, I think it could be equal now. What? Come on. Or maybe it starts off at 0. Yeah, I got kind of confused myself here. Come on. No, no, no. Try to go fast here. Try to go quickly. I have the idea, but it's tricky to code. These questions are all like that, man. They're all like tricky to code. They're always like complicated, more complicated than they need to be. That's annoying. All right. So shoot. Shucks. All right. What is happening? I don't know. I did something wrong. I did something wrong. Okay. So at some point, zero to 8, 9, 0 to 9, 0 to 9. It just kind of keeps going over and over again, right? We always lose the mid value. Always update the best value. It's actually not the calculation that's wrong. This is actually exiting, right? You gotta be kidding me. What's wrong? What is wrong? Okay, so it's not looping infinitely on this part. It's actually the binary search that's looping infinitely. That's surprising. Really? What is going on? What? I'm so confused. I don't know what's happening. I don't know what's happening. Also, I don't know if the count is correct either. It could be another issue. Oh, it's supposed to be like very straightforward, but it's not working. What? Where is it TLEing? What? What is going on? What is happening? Hello? Which one is it TLE? Which one is the TLE? What? That doesn't look like a TLE. Huh? 15 it stops, 6 it stops, 2 it stops. Oh. That got something to do with it. I'm very confused. Well, when it's 2, okay, I think this is wrong. Let's start with that. So, this is always going to increment the count by 1, right? So we put a bunch of things into the ship, right? We increment the capacity a bunch. We increment the count afterwards. Increment I a few times. So the first iteration, we have some things that we processed. We're at I somewhere, possibly at the end. We increment the count by 1. Then we start again, and we process some things. What is it? What is going on? Sometimes I don't know what I did wrong, and something's wrong. It's very annoying. It's not that complicated of a question. It's just difficult to get it correct. Okay. So here, this one just stops, right? Val 5, days 5. Does this restart? What happened here? What happened here? Hello? Oh, no, mid comes first. Excuse me, mid comes first. Okay, got it. Yeah, so we end up with 5, the first one. Or, excuse me, 15. End up with 15 for the first one. Oh, you know what? This is supposed to be... Well, actually, it's going to get smaller, right? How does this work? Yeah, if the value is less than or equal to days, then it should be the smallest one. Yeah, this is fine. This is fine. So now at mid is like 500,000, whatever it is. Say val days. Val is 1, days 3. Right, as much capacity as possible. Then we say try 11, takes 2 days. 5 takes 4 days for this one. Gotta go higher. Go to 8, takes 3 days. Go to 6, takes 6 days, and we're done. Okay. So it's this last one that loops too much, right? Val is 1, days 4, mids 95. Right, 95, we do this all in one day. There's only 6, 7, 8. As long as mid is anywhere greater than 8, it's going to take 1 day. So 11 takes 1 day, 5 takes 2 days, and mid 2 is just shot. Okay, well, here's the problem. This doesn't work with things that are less than a weight of 2. So I can't actually ever go below 2 for A. How did this happen? What is going on? A only ever increases to mid plus 1. B decreases to mid minus 1. A is less than or equal to B. A is the smaller value. A plus B minus A is the larger value. B minus A divided by 2. A plus B minus A over 2 should be A plus B over 2. I should never get 2. How did I get 2? What is going on? So that's the issue, is that, yeah, it's looping infinitely here. It is looping infinitely here. I was trying to like maybe test for, take a look at this test case. But I don't know. I kind of didn't think it mattered, but I guess it does matter. It takes infinite days, basically. So if weights of I is greater than C, then we need to break. In fact, we need to return infinite number of days, which is too many days. I mean, maybe that's all I need to do. Maybe I should have just done that initially. I was trying to think that through. Like, how do I do this? Keep it simple. That's probably the simplest way to do it. Yeah, at any point, if the capacity is too low, then you just, all right, well, whatever. So apparently it is possible to dip below. I didn't even think that was possible. Also, where are these print statements coming from? I didn't even think that was possible, that I could end up somewhere below the value of A. That's like, what? How does that happen? What do you mean? What was A and B that I got 2 an infinite number of times? That I even got 2 at all? How did I get a midpoint between A and B inclusive that was less than the lower bound? How's that even possible? Excuse me. What is going on? That's so confusing. I don't understand. How is that even possible? What? Unless I made a mistake somewhere. I don't realize it. I don't know what I did to get that to happen. This should have been a very quick solution. I figured out a reasonable solution very quickly, but I just apparently didn't program it correctly. Well, little unexpected here. I don't know. Yeah, so A is 1. So somehow, even with A, oh, I know I did wrong. Oh, that's bad. This is actually a pretty good solution too, but there's a different, oh, I see, I did wrong. Okay, That's a really easy mistake to make. I know what I did wrong. This should have been so much faster. This should have been so much faster to complete it. But let me go for it, see if it's correct. I think it's right, but we'll just try it, see if it's. Oh no! Oh, oh, no! Getting too ahead of myself here. It's not correct either. Oh my goodness. There is another solution. I'll explain in a minute what the other solution is. Runtime error. What? No. It's killing me. I think it's got to be here. This one. Maybe that's the issue. How? Oh. Jeez. All right. Of course. Is that it? Was that the issue? My patience is like gone. Okay. No. Oh, that's so bad. That's so bad. I didn't even think about that. Oh my goodness. That's so disappointing. Yeah, this is not that hard of a question. This should have been very quick to program. Should have gotten it correct the first time. I just kind of goofed it up. So instead of having this if statement, by the way, you could do the mistake that I made was not. It's not supposed to be the min element. It's supposed to be the max element of weights begin and weights end. That was what I needed to do here. And then I don't need that other if statement. Fairly certain that's what I needed to do. That was the error before that I didn't realize. That's so bad. It should have been so fast. It should have been so fast. I'm gonna submit it a bunch of times. 1, 2, 3, 4, 5. It's a lot slower than the other solutions though, which I'm kind of surprised. Maybe there's actually a faster way to solve this that doesn't involve this kind of thing. But this is kind of like an approach that I would take typically. Maybe this needs to be inlined. Maybe that's the issue. 3, 4, 5, 6, 7. Yeah, it's like really slow compared to the other solutions. So yeah, I wanted to say that oh no, I got it wrong, and I didn't realize that I could. Yeah, there's a couple of things. It wasn't supposed to be the min weight element. That was the problem. It needed to be the maximum weight element, which I just kind of blanked on. And then that was why I was able to. The midpoint was able to drop below. And then I also needed to do. Actually, yeah, I also need to do this. These don't need to be this large, by the way. This might have something to do with this. I don't know. Can I do this way? E6, 25 E6. Does that still work correctly? Yeah, there's like there are a lot of things to say about this. Oh no. Oh no, man. Gee. Yeah, we could put the if statement in here too. I don't know what else to say here. So many mistakes. It should have been so fast. This should have been really fast. This could be inlined here, obviously. This could just be val instead of count. Actually, you don't even need val, you just do count. And then, all right, this should work too, I think. Gotta take a deep breath. It's like, oh, man. Wow. That's a lot faster. Yeah, that's a little bit better. And don't really need to say if weights of I is greater than mid, then we can break and set the count to set to B or something. Best plus one. Or days plus one, yeah. Probably better. You do it this way too. I think that also works. Try that. Oh, I'm so disappointed. I'm so disappointed. This shouldn't have been so hard. This should not have been so difficult. No, should have been so much faster. But yeah, basically, I had the right idea very quickly, and then two big errors. One, I didn't really write this totally correctly, and it kind of depends. Yeah, like I didn't add a failsafe here, and then because I didn't add a failsafe there, it was important that I did this part correctly, set the value correctly for the bound, but I set that incorrectly, so I had no failsafe and I didn't set that correctly. So I was getting the wrong answer. And then I put in the failsafe, but I put the failsafe in the wrong spot because this will loop infinitely, it seems, which I didn't really think about that either. Didn't think that all the way through. Yeah, and yeah, I made a mistake. I made a mistake. So that was bad. Didn't implement the failsafe correctly. Then I assumed if I didn't have to actually implement the failsafe, but if I set up my bounds correctly, but I didn't set my bounds up correctly, so I ran into a whole bunch of issues. And after all of that, it's not a very fast solution, which is kind of disappointing. There's probably a way to do this. It's a little bit more efficient. I don't know it offhand though. I think it might be faster if I think it might be faster to actually start my capacity at the sum of the weights. The sum of the weights divided by 3 or something. Yeah. So divided by the days. Let me try that. Maybe that's what I should be doing. Maybe that'll make it faster. Because I think this is probably I could try this one too. That might be the way to make it faster, because it's just a lot of extra computation. I don't do it that way. Yeah, that makes it faster. Makes it quite a bit faster, and then I could remove this too, as mentioned. Just let this be the max element. Okay. This may or may not be any faster, I don't know. Let's see. No, not much quicker. I don't know if this is the only way to solve this. This might be may not be the best way to do it. Yeah, if weight to buy is greater than mid, then it's too high the capacity. What I had before. Yeah, I mean, okay. Let's look at some of the solutions because my solution's kind of slow, and I'm kind of annoyed. I don't know why it's so slow. Let's do editorial first. Oh, okay. Do not. Binary search. Faster, easier to understand. Binary search. Let's do most votes. There's a whole bunch that are very similar to this. Huh. Maybe this is why it's faster, is because maybe the problem is that I'm doing a lot of extra computation here that I don't need to do. All right, let's try to modify. I think that's the issue. It's that I'm just doing too many. Yes, it's the same. It's the right answer. It's just I'm using too many operations. It's not as efficient as it should be. So first off, we don't need I. We can just do okay. Then we say well, okay, we could still have the failsafe in there. Then maybe not having the failsafe is better. Could actually do this in one loop too. The 2 passes, or yeah, one more pass. Okay, that's fine. And we don't even need this actually, but we'll come back to it. Yeah, I don't know, man. Sometimes folks, they're a little bit better about setting up their binary search where it's like not, it's a little bit, it'll just say it's a little bit better than the way I tend to do it. Where they don't need a third variable. Notice people doing that, and it's a little weird for me because I'm like, I always have that third variable. So I don't need that failsafe anymore. So what did he do? He said if, so there's a current value. It gets set to 0. And he said if current plus this weight is greater than mid, then we've got to increment count and the current set to 0. Otherwise, we just set the current increment up. Yeah, otherwise, well, actually, no, we always add. Okay, so instead of using a second for loop, you can just use an if statement, which is a little bit better, I think, than using a second for loop. So we can just, yeah, because the second for loop, it's a little more complicated, right? Like you have to do a lot of extra arithmetic than is necessary. I think that's why my code was so much slower. So we go through each weight and we say, okay, our count is 0. If the current plus the weight is greater than the mid, then we need to put that into a new boat. So increment the new boat, and we start with one boat. Okay. So start with one boat, and if our boat won't fit, then we need a new boat. And we always add this weight to the boat. So that's an easier way of doing it than the way I had done it. And then finally you say, okay, if the number of boats or number of days is less than or equal to days, then we've got. Now the way they did it was left and right is equal to mid and mid plus 1. So interesting. What gets confusing about this is I'm looking for the minimum, right? If I'm looking for a minimum, if I'm looking for the smallest value from right to left where it's true, I don't need my third variable, my best variable. Because I can basically guarantee that everything I check is within this interval. So we don't actually need this best. And what we can do is say, okay, if we're less than or equal to the days, then we can update, we want to go down, so we can update B to mid, and I think this is actually faster if you do it the other way around. If you do it greater than days, you need to go larger, and less than or equal to days, you go to the mid, and then you can return A. Okay, this is basically the same code as what I think one of the better solutions has, the faster solutions has. Let me see if this is always correct. Yeah, that's faster. Okay, it's quite a bit faster. Let's try again. Let's keep submitting. So, yeah, that's way faster. You see that now? Okay. Great, but kind of disappointing that my code was so slow. Number one. Number two. What else to say about this? That's much better. Yeah, it's like twice as fast. I think these are, yeah, all these other solutions are like the same idea. It's a binary search over the possible output. This is definitely better. Definitely coded with fewer operations and whatnot. I guess the problem I have is like, how do you know? So when you have a binary search and you're looking for the, basically you can translate to zeros and ones in an array, right? Trues and falses. And you're looking for the leftmost position where you have a true value, right? The smallest one, the smallest indexed one in that binary search. When you're in that scenario where you have zeros on the left side, ones on the right side, you can use a binary search like this and just have A less than B. And if your condition is met, then you're going, and you just have to start, within a range to search. If your condition is met, in other words, you see a 1, then you just move the rightmost B down to that point, right? So that midpoint B equals mid. If your condition is not met, then you can move A to a mid plus 1, right? You can remove that midpoint. And eventually A and B will be equal to each other. And that's guaranteed to be on some value of 1, and you can return that value of 1. A few things to say about this. Number one, what about scenarios where none of the conditions never met, right? What if there are no ones ever, right? That's one issue. And the other situation considers, what if these things are flipped around? What if it's you're looking for zeros, the rightmost zero, I guess the position where the condition is not met, right? And I guess what I'm saying is you're looking for the largest. If you flip the bits to ones and zeros, you're looking for the rightmost value, the largest value where the condition is true. That's similar to finding the smallest value where the condition is not true. Flip all the bits and look for the smallest one. However, you have to decrement by one again there. And what's awkward about that is, what about when things are full or empty, right? Like how are things handled when things are full or empty? So in this scenario, there's always a position where the condition is true. So there's always a one somewhere in the range. But what about a situation where it's possible that there's no one in the range? In other words, whatever range you're looking through, it's just always zeros. Well, a binary search like this, I think, may run into issues in that scenario. And that's kind of what I've been struggling with trying to use three variables or not using three variables. If you can't always guarantee a value of something being true somewhere in there, then what can happen is your B value will keep coming down all the way down until A and B are equal. And then it stops, I think. No. So what can happen is the midpoint's always on the left side. Actually, when you take the midpoint, it always defers to the left side. So yeah, it'll eventually come down to be equal to A. If B comes down. Yeah. It works in that case too. There are no ones. Yeah, and if you want to do the other condition where you're searching for the largest value where there's a one, you just flip all your bits to flip the condition, and then again you're searching in the range where it's the values that are possibly true, and then you stop at A, right? Or wherever you stop at, and then you just subtract one from that, right? And so I think the other scenario where I got stuck on this, the other binary search I was stuck on was, let's say you're looking at the bottom. Let's say you're trying to count the how do you express it? Trying to count the number of nodes in. Well, actually, let's just make it that analog, right? You just have a bunch of ones and zeros. You're trying to figure out, and it could be all zeros, and there are a number of ones from left to right. You're trying to count the number of ones there are from left to right in an array of just ones and just zeros, and trying to do it in logarithmic time. Excuse me, and it's guaranteed that all of the values from left to right are going to be either all zeros or a sequence of ones and then zeros, or a sequence of ones. It's gonna start with a sequence of ones that could be zero or more characters, or zero or more, one. Yeah, zero or more characters. One or more. Yeah, zero or more characters of ones. Yeah, so in that case, you'd actually want to flip the condition, and you're searching for zeros, the smallest zero value, and then once you find it, you subtract one to give you the largest position of a one. Yeah, that works. That's fine. What if there are no zeros? Right? What if there are no zeros? Oh, I see. Yeah, if there are no zeros, then you would return with well, you could just check. Just check the value at the end of your range. Um is it, if it doesn't check out for that value at the end of the range, then that, you're in that situation. So you could just use a simple if statement before the binary search. Not actually that big of a deal. That's not that hard. I don't know why it's such a hard time with that. Yeah. Let me think here. Hmm. Yes, you don't need a third variable. You just have an if statement there. That's fine. Yeah, flip the condition, and then if it's possible to not have any zeros at all, right? Or not really flip the condition, but just search for the smallest zero value from right to left, and then in that case, it's possible that you don't have any zero values. You still don't need a third variable. You can just have an if statement to check to see if the condition is even met at B at the end of the range, the rightmost part of the range. If it's not met at the rightmost part of the range, then it's not going to be met for anything in between, right? It's a binary search, so you can just stop immediately. Yeah. Well, that's interesting. I don't know why that was so hard for me to think that through the other day. I guess I'm used to binary searches where it's guaranteed that the condition so you can always use a two variable binary search given that you're looking for the largest true condition, the smallest true condition from left to right. Then a two variable binary search just like this works just fine. However, you may be looking for actually the largest value for which the condition is false, in which case then it's possible you might run into trouble, because if you flip the bits, you might run into a situation where actually it's never true. What you're looking for, you could just find the smallest value where the condition is false, and then subtract 1. And you could use a two value binary search to do that, but it won't be possible to do that if none of the values if none of the values are 0 anywhere, right? If the condition is if the flipped condition can't be found anywhere within the interval. Yeah, that gets confusing. I think in that scenario, you have you just use an if statement. That's all. And you would, you basically just your solution is going to be just the last value of the range at that point. However, the question is, well, yeah, that's it. That's fine. How does the binary search work in that scenario? Well, it's going to just keep incrementing A all the way to the right, right? But it can go off the edge. Yeah, that's interesting. It'll actually still work correctly in that scenario too, because A being moved left to right, it'll stop when A is equal to B, which is actually the point that you want. No, but you don't want to subtract 1. That's the point. Yeah, that's where it's a problem. Right. A will stop at B, but so it'll actually still work, but it will be you have to actually add 1. That's interesting. Huh. It's kind of ugly if you just have like a big branch statement. You could just have a check, a quick check at the right bound. works or not, and then you can just add the value at the end. I realize it's confusing. It's confusing. What I'm describing is confusing. But it's, yeah, you should be able to use a 2-variable binary search. I don't think it's probably better just to use the if statement if the b value it's not satisfied even on the b value. This kind of a setup, you basically want to guarantee that there's always some value somewhere it's true in the range. Well, no, it's fine if it's not true anywhere. It's not true anywhere. It's really confusing. That's kind of where it gets confusing. Is that if you don't have any true values any true values in your binary search range, then it's a little weird. It's a little weird. That's what I'm getting at, and it's not as obvious how to handle that when you're using 2 variables. And then especially if you have the reverse, where you have a whole bunch of, you're actually looking for the largest true value rather than the smallest true value, largest index true value or the smallest index true value. It's equivalent to flipping the condition and then searching for the smallest true value and then subtracting 1. But the problem with that is you can run into the same scenario where it could be never true or something like that. When the conditions flip. So yeah, got to be careful around those sorts of things. That seems to be the thing that trips me up when I think about binary searches. Also, whatever condition you use to perform your calculation, or not condition, but like subroutine to perform this calculation for the binary search, it's very easy to make mistakes on that. Kind of got to think through the logic a little bit. This is probably the one that's you're gonna see most of the time. Like almost all of them kind of follow the same format, where you basically just have a count of 1 and then some current amount. You increment that current amount with the weight as you go, and then if you can't fit, then you update the count and current value amount. Just keep going. Yeah, interesting solution and problem. I thought that I was like gonna just solve this really quickly because I recognized it for what it was, and I thought it was gonna be very quick. It should be really quick. It should be like literally should be like 3, 4, 5 minutes. This question, and I've seen it so many times. There's so many variations of it, but I just for whatever reason did not solve it correctly this time around. Had to take some time to think about it some more. So anyway, I guess you always kind of improve a little bit more as you go, right? In the future, I should be faster and should be able to do it, correctly and quickly, and the solution will be efficient. All those things kind of all at the same time. So anyway, thanks for watching. If you liked the video, give it a like and follow the channel. I'm going to stop this video and start another problem, another live stream with a different title for the video. So I'll be back. But yeah, interesting. Got kind of, yeah, I mean, I learned something. I definitely learned something. I got it wrong, which is annoying. There were a bunch of things there that were, these are tricky questions. They're tricky, challenging. All right, I'll